Hi, this is Mrs. Kidman, and in this video, we are going to be discussing how we can solve radical equations. So what do we mean when we talk about a radical equation? Well, what we're talking about is an equation that has a radical in it. Surprise, surprise. So for example, what we're going to be talking about today is solving some either where the radical's on one side or we have radicals on both. So when we're talking about solving these, what we want to do is try to get the radicals by themselves. So let's take a look at an example here that we can kind of walk through together and see some different algorithmic steps that we can follow to help us solve these. So an example of a radical equation that we might solve for would be the square root of 3x plus 7 minus 4 equals 12. Or maybe let's go with 1 equals 1. Perfect. Okay, so what we're going to do here is we want to solve for x. Ultimately, solving radical equations means what x value do I need to put in here to make this true, just like how we would solve before. Now, when we solve these, we're going to follow a couple steps. The very first step is to get the radical alone or by itself. So when we talk about getting the radical alone, what that means is, do you see how this one has this plus 4 or this minus 4 attached to it? Because it has that 4 there, it's not all by itself. And so then if we were to try to square both sides, we would have to do some FOILing. So what we want to do first is get the radical alone by moving everything else to the other side. So move everything to the other side. And so how would we do that in this equation? Well, if we're going to move everything to the other side, what we would do is we would actually add that 4 to both sides, so it gets rid of it on this end. So we end up getting that square root of 3x plus 7 equals 5. Now that we're at this point where it's all alone, one thing that we need to do, this is like an intermittent step, a kind of step 2, is check if it's a square root, or really any even root, so a 4th root, a 6th root, an 8th root. If it's an even root, then we want to see if it equals a negative number. If it equals a negative number, what we're going to do is we're actually going to stop, because if it equals a negative, there are no solutions. And why are there no solutions? Well, think back to when we were talking about graphing radical equations, and we graphed the function, the square root of x. Remember how it looked like this? And how it wasn't on this other side at all. There were no negative x values that we could put in there. So whenever it equals a negative inside, because I can't take the negative of a square root and still get a real answer out, we aren't going to solve it because we know that what's inside can't equal a negative. So what we're going to do here is we're going to stop solving it and say there are no real solutions. So in this case where we don't have a negative, the next thing we're going to do is step 3, which is where we put it to the power of the type of root. So what does the power of the type of root mean? Well, what we're talking about here is, do you see how this is a square root? Well, a square root really has that little 2 here. We don't write it, but that's what it is. So if we're going to put it to the power of that type of root, what we're going to do is put both sides to the power of 2 here. And the reason why we're going to put both sides to the power of 2 is, remember, when we're solving equations, whatever I do on one side, we have to do the other. We have to keep it balanced. So I'm going to use that 2 there because the opposite of a square root is squaring something. And so if I square a square root, it just gets rid of that sign. And what I'm left with on this side is 3x plus 7. Now again, because we can't just do it on one side, we have to do it to both, which ends up getting us the answer of 25 over here. And then what we can do is solve for x, and this becomes a 2-step equation. We can subtract 7 from both sides, and we get 3x equals 18. And then we can divide both sides by 3 and end up getting ourselves that x equals 6. So that's how we would solve it. So after we do that power of the type of root, the last thing we are going to do is solve for x. And at that point, we really should get something like this. Now, sometimes when we're solving, we might have to factor, we might have some other little things there, but for the most part, these are the steps we can follow. Get the radical alone, meaning moving everything to one side. Then if it's a square root or an even root, make sure it's not equal to a negative. If it is equal to a negative, there are no solutions. Then we're going to put it to the power of whatever type of root it is and then solve for x. So let's take a look at a couple of examples here where we're going to solve these radicals. So this one here, notice how there's nothing other than the radical on one side and the number there. It's an odd number root, so we don't know what it is, so it's fine for it to equal a 5. So then that third step there is to put it to the power. Because it's a cubed root or a root of 3, we're going to put both sides to the power of 3 and we end up with x minus 1 on this side and 5 to the power of 3 on the other side, which is 125. Then we can add 1 to both sides to solve for x, and we get 126. Fantastic. So that is essentially those steps that we're going to follow. Let's look at a couple more examples here. And really, again, there are going to be different steps that we see, but we all have that same goal of getting that x by itself. So with this problem, notice how there's this 2 out here. Now, that very first step says that we need to get x all by itself, or that radical by itself. And so this 2 is actually preventing our radical from being alone. So the very first step we want to do is actually divide both sides by 2 and get rid of this 2 here. So as we divide both sides by 2, we end up with x plus 1, the square root of x plus 1 equals 2. And then we can get rid of that root. Now remember, we want to check the square root is even, so we need to make sure it equals a positive number, in which case this does. So we can square both sides. We get x plus 1 equals 4, which means x equals 3. Fantastic. Okay, let's take a look at one more example here. In this case, we have the cubed root of 2x minus 9 minus 1 equals 2. And so with this problem, what we want to do is follow those same steps, just like we did before. We're going to do this process over and over again. So with this one, we are going to add 1 to both sides here, and we're going to end up getting the cubed root of 2x minus 9 equals 3. Now remember, we want to move everything that's not included in that root. So right now, we only have the root left on this side. So then we need to ask ourselves, is this an even number root? Because this one is not an even number root, we are good to have whatever here. And so after we have that point here, we want to put it to the power of whatever this root is, so to the power of 3 on both sides, and we end up getting 2x minus 9 equals 27. And then we can solve for x just like we were doing before by adding 9 to both sides, and we get 2x equals 36, and we can divide both sides by 2 and end up getting that x equals 18. Awesome. So that is what we're going to do to solve those. Now, one thing that I want to keep in mind is this idea here where we were saying we want to check to see if it has no solutions. But sometimes what we're going to run into is something called an extraneous answer. And what does it mean for an answer to be extraneous? Well, what it's talking about is sometimes when we solve these radical expressions, we end up getting something that looks like this. So here's our radical when it gets graphed, right? Our square root. But sometimes when we solve for them, our radical thinks that it's actually a quadratic turned sideways. So it will give us 2 answers. But this answer doesn't actually exist, right? That wasn't a part of our function. And so when we go to do this, we need to check to see if we ever run into this problem. Because in this case, what we need to be aware of is the square root of 16 is equal to 4, not negative 4. And so every time we're solving something with a square root like this, we need to make sure that we're keeping it with just that positive answer. And so if we ever end up with the square root of something equaling a negative, that's when it becomes that extraneous answer, where it's not something that we include. So let's take a look at a couple of examples where we will get some extraneous answers and how we can check to see what they are. So let's start with this problem here. So again, we're going to follow those same steps. Get the radical alone. And then we want to check to see if it equals a negative when we have an even root. Then step 3 is to put it to the power of our root. And then step 4 is to solve, just like we were doing before. Okay, so let's go through this one. We have our radical alone. Our square root or our radical, it's even, but it doesn't equal a negative. So we're good to go. So now let's put it to the power. This is a square. So we're going to square both sides, and we end up getting 90 minus x equals x squared. So what we're going to do here is this right here is hard to solve. So what we're going to do is change it into a quadratic equation and then try to factor it. So I'm going to add x to both sides, subtract 90, so get everything to the same side, and I end up getting 0 equals x squared plus x minus 90. Now, in a problem like this, we can now solve it using factoring. So I'm going to factor this, and I'm going to ask myself, so what are 2 numbers that multiply to negative 90 and add to 1? Well, that's going to be negative 9 and 10. So we end up getting that x minus 9 and x plus 10 equals 0, meaning that x has 2 answers here. It can either be 9 or x can be -10. Now, fantastic. This is stuff we were doing in chapter 3, this previous unit. But now that we have these, we need to check, or this last step here that we didn't have before, we need to check to make sure that we don't have any extraneous solutions. So check for extraneous solutions. Solutions. Okay, so how we do that is we take both of these answers, plug them back into our original equation and see if it works. So if we plug 9 back in, we end up getting the square root of 90 minus 9 equals 9. Fantastic. We've got a square root equals a positive, the square root of 81. That does equal 9. Perfect. Okay, now let's check this next one. We've got the square root of 90 minus -10 equals -10. And then we get the square root of 100 equals -10. Now, typically we say that -10 times -10 is 100. However, in this case, we know that the square root of 100 is going to be 10. And because 10 is not equal to -10, this is not a possible solution that we can use here. So we don't want to use it. That's called that extraneous solution. So it would work if our function looked like this. But because our function is only this side over here of that equation, we cannot use this answer of x equals -10. That's not going to be a possible solution that we see here. So let's take a look at a couple more examples here in which we're going to practice this same skill. So let's take a look at this one. Again, remember that what we want to do is we always want to move whatever we have to the other side so the radical is alone. So I'm going to start by adding 3 to both sides here. And we get the square root of x plus 9 equals x plus 3. And then we're going to square both sides. Now, notice how we typically combine things that we can here. We can't combine that x, so we end up getting x plus 9 equals x plus 3 squared. But what is x plus 3 squared? Well, we're going to have to FOIL that out with that x plus 3 times x plus 3. And as we FOIL it out here, we end up getting x squared plus 3x plus 3x plus 9, which ends up being x squared plus 6x plus 9. Now, once we get to this point, we want to move everything to the same side, so it's equal to 0. And so that involves subtracting x from both sides and subtracting a 9 from both sides. And we end up getting x squared minus 5x. Okay, so then once we get to this point, what we want to do is check our answers here. And so we end up getting 0 equals, I'm going to factor out the greatest common factor, x minus 5, not plus 5. So our two options for x are x is either 0 or x is 5. Now we want to check to see if we get an extraneous solution here. So how can we check to see if we get one of those? Well, let's plug them back in. So if we plug 0 in here, we get 0 plus 9 minus 3 equals 0. Well, 0 plus 9 gives us the square root of 9 minus 3 equals 0. And that would work for us, right? We end up getting 3 minus 3 equals 0. Perfect. Okay, the next thing that we want to do here is we want to, oh, this is a plus here. Ooh, awkward. The next thing we want to do here is actually check this next question by checking our -5. So I'm going to put a -5 in here. -5 plus 9 minus 3 equals -5. Now I can add 3 to both sides here, but we still end up getting the square root of -5 plus 9, which is 4. So the square root of 4 equals a -2. But we know the square root of 4 is actually a positive 2. And so those are not equal to each other. So this solution does not work. So that's kind of how those extraneous solutions work. So let's take a look at one more example of how we can solve these radical functions when they're given to us in radical form here. So let's take a look at this one where it has a radical on both sides. So remember in those steps initially, we wanted to get a radical by itself. Now where both sides have a radical, we're going to just leave those radicals where they are. And so we've already gone past step 1. Step 2 doesn't work because neither of these are negative. So now we just want to put it to that, we want to multiply it by whatever that power is. Now we can only multiply it by that power if these numbers underneath are the same. Because they're both a 3, then we can actually get rid of both those radicals by multiplying them both to the power of 3. So let's go ahead and do that. And we end up getting 4x minus 9 equals 2x minus 4. And then we can solve here. So I'm going to subtract my 2x from both sides and get 2x minus 9 equals negative 4. And then we can add 9 to both sides, and we get 2x equals 5, and then divide by 2. And we end up getting x equals 5 over 2. Perfect. Okay, there's one last thing that I want to talk about before we finish on this idea of solving radical equations. Now remember, radicals we often see with these radical signs. We see a square root, we see a cubed root, a fourth root sometimes, but a radical can also be written using a rational exponent. Now remember that this right here is another fancy way of saying the square root of x minus 27 to the power of 3 equals 64. So there's a couple ways that we can do these ones when we see these radical exponents. One way is to rewrite it and then follow through our steps. We can square both sides like this. And then we're dealing with x minus 27 to the power of 3 equals 64 squared, or 64 times 64, which is 4,900 or 4,096. But then we need to get rid of this cubed, and we have to cube root both sides to get rid of it. And it starts to turn into a little bit of chaos where we're squaring and then square rooting and then squaring and then square rooting, and we get this x minus 27 equals 16, and we keep going on from there. Now, that way works every time, but what I want to show you is another way that we can do it. So let's finish out this problem here, and we end up getting that x equals 43. Now this works, but we had to rewrite. So we had to rewrite to go from here to here. Then we had to square. And then to go from here to here, we had to cube root and then solve. And so I don't know about you, but sometimes squaring and then cube rooting and things like that can get confusing. So another option that we have is we can, just like we did before, get whatever the quote unquote radical would be all by itself. So in this case, that would mean anything that has a fraction exponent. If I can get this alone, then what I can do is multiply it by something that turns my exponent into 1. Because remember that property that says any number to the power of, so if I had like a to the power of 3 to the power of 2, that we would multiply these two and it would become a to the power of 6. So what we want to do here in this case is we want to take something to the power of 2/3 and turn it into a 1. So we can multiply it by its opposite, so 3 over 2, because 2 times 3 is 6, and we'd end up getting 6 over 6, which is just 1, which means we just have that a. So that's our other option, and that's what we're going to do here. So I'm going to start by adding 3 to both sides, and we're going to end up getting 2x plus 12 to the power of 2/3 equals 16. Fantastic. Now, again, we can always use this method over here. But what I would recommend doing is we can put all of this, I'm going to do it in a different color here just so that we can see the difference. I'm going to put all of this to the power of 3/2. Now again, we put it to the power of 3/2 because of this example up here. If I flip the fraction over, then my numerator and my denominator become the same, and all we have left is that base. So what we're going to end up with here is that 2x plus 12. But remember, whatever we do on one side, we have to do to the other side. And so then as we're putting it to that power, what we need to look at here is 16 to the power of 3/2. And so what this ends up giving us is 64 when we put it to the power of 3/2. Then we can go ahead and solve this question just like we were doing it before by subtracting, and we get 2x equals 52. Which results in x equaling 26. Now, both of these methods obviously work. You can choose which method you want to do, but that is how we can rewrite those expressions using those rational exponents. So we can either rewrite it and then have to do both an exponent and a radical to get those x's by itself, or we can multiply it by another rational exponent that turns those exponents into 1 and then solve it that way. Both methods work fantastic. It's totally up to you which one you do. So keep that in mind. We can either rewrite and then follow through our steps to solve, or we can multiply by the reciprocal and then proceed on. But just to culminate the review of this video, I want to remind you, when we solve radical equations, we're going to follow a couple of simple steps every time. So step one, we are going to get the radical alone. And that doesn't mean that it needs to be just the square root of x or the cubed root of x, but that means there's nothing added to or multiplied on the outside. Once we have that, we want to check to see if it equals a negative. And that's when we have an even numbered root. So a square root, a fourth root, things like that. If it does, then that means that there are no solutions. So for example, that would be something like the square root of x plus 2 equals -6, right? There's no number we can put into there to make a square root equal to a negative. So this has no possible solutions. Now, once we've checked to make sure that there are actually solutions, the third thing we're going to do is put it to the power of whatever our root is. And so remember, the power of whatever our root is would mean if we have a square root like this, we would put it to the power of 2. If we have a cubed root, we'd put it to the power of 3, a fourth root to the power of 4, et cetera, et cetera. And then the next thing we're going to do is solve for x. And that involves the adding and the subtracting and all those beautiful things. And then the very last thing that we want to do is check for those extraneous answers. So those ones that pretend to exist but don't actually. And so again, remember, we check for those extraneous answers by plugging it in. So we want to plug it in and see if we get a square root equal to a negative number. If we get a square root or fourth root equal to a negative, then that is not a solution, as we know because we checked it in step 2. So make sure that we run through that process by substituting it in and seeing what we get. If you have questions, feel free to reach out, but that is how you can solve radical equations following this simple method and how we can even check for extraneous answers. And last, we can also, when they give us those rational exponents, solve those ones as well. So again, feel free to reach out if you have any questions, but that is how you can solve radical equations.